Welcome to my fourth video from the Polynomial Check for Understanding from April. I'm going to focus on the second part of part 3, which was factoring polynomials. We have 3c, which is 9x squared minus 121, and 3d, which is 36x squared minus 60x plus 25. And then we have 3e, which I might put on a third video. We'll see how long this goes. Or should I say a fifth video. At any rate, we're going to be factoring each of these. And I single out 3c and 3d because they are special cases. Okay, so 3c is a difference. And you might notice 9x squared is a perfect square. And 121 is a perfect square. So this is a difference of squares. We have a square term in the beginning, and we have a constant term at the end, a 0-degree term. And there's no middle linear term, so we don't go 2, 1, 0 in our steps of our degrees, which means something happened to that middle term. It got canceled out. The only way we can cancel it out is we have a plus inside and a minus outside. My inside and outside, I should say. When I FOIL it, I might FOIL my factors. When I FOIL them, my inside and outside are opposites, so they cancel out. Now, the difference of squares structure is if you have a squared, squared minus b squared, that equals a plus b and times a minus b. Okay, these are Tweedledee, Tweedledum cousins. So a plus b and a minus b are what are called conjugates of each other. So you have the same two terms, a and b, but one is a sum of those terms. The other is a difference of those terms. If I FOIL this, a times a becomes a squared. So my first is a squared because a times a is a squared. Then my outside is going to be minus ab because it's a times negative b. Then my inside is b times a, which is the same as ab, but it's positive. You now have two terms that are opposites of each other, and they are going to end up canceling out. Now my last part is b times negative b, which is going to be negative b squared. Not the square of negative b, but negative b squared. So these middle two terms are going to go away. Say bye-bye. Bye-bye. They go away. I strike through, and they're gone. And I'll rewrite this as a squared minus b squared because that's all there is. So if you look at this structure, you can see where this is my a squared, 9x squared, and this is my b squared, 121. So I'm going to rewrite this as two binomials, a product of two binomials. My first one is going to be my a, and if this 9x squared is my a squared, then my a has to be the square root of that. It has to be 3 times x, so 3x. And I know I'm going to also have 3x here. And instead of one of them is going to be addition and one of them is going to be subtraction. So if I put plus here, I put minus there, because this will allow me to cancel out my middle terms. Now my last part, my b, comes from my b squared. My b squared is 121, so my b has to be 11. So plus 11 and minus 11. And we have factored it. Now we can test this out by FOILing it. Okay, 3x times 3x is my first, so that's 9x squared. My outside is 3x times negative 11, so minus 33x. My inside is 11 times 3x, which is positive 33x. Those are going to cancel out. My last is 11 times negative 11, which is going to be negative 121. That middle stuff goes away. Say bye-bye. Strike through, it's gone, and I'm left with 9x squared minus 121. And again, special cases, you got to learn them. They're really important, and they will make your life easier when you're trying to factor something. If you see a two-term quadratic where the first term is square, the last term is first degree, there's no linear term, be suspicious. You might have a difference of squares. You can probably actually convert anything that's a square term minus a linear term into a difference of squares, as long as you're willing to get the square root of each of them. In this case, it's a neat and tidy square root. Square root of 9x squared is 3x. Square root of 121 is 11. So we get 3x minus 11, 3x plus 11 as our two factors. Or 3x plus 11 times 3x minus 11, however you want to say it. My next one is a perfect square. And the first thing I do to figure that out is I notice my first part is perfect square. 36x squared is 6x squared. And my last is 25, which is 5 squared. So when I see that, that might be a perfect square. The key is what's the middle term. So my middle term, if this is a perfect square, then my middle term has to be 2 times a times b, or 2 times the square root of this times the square root of this. So if I factor out 2 from this, I'm left with negative 30x. Okay. Now negative 30x. Now I know what I now need to do is see what happens if I factor out what my a is, what the square root of 36x squared is. If I divide that by 6x, which I got from getting the square root of 36x squared, I am going to be left with negative 5. Now my last test is to see if negative 5 squared is 25. And it is. So my middle term, negative 60x, is 2 times the square root of my first term, 6x, times the square root of my last term. And since this is negative, it comes to be the negative square root instead of the positive one. So if I put all that together, I am going to end up with negative 60x. This is a perfect square. The perfect square structure is either a plus b squared, okay, which is going to equal a squared plus 2ab plus b squared. Or if I had a minus b squared, it looks exactly the same except my middle term is negative. So I end up with a squared minus 2ab plus b squared. Looks just the same. The only difference is that I've got this negative. So when I see this negative and I've figured out it's a perfect square, then I'm going to know that my lead is going to be this, the square root of this, which is going to be 6x. And then I'm going to have not the square root of 25 is not going to be 5. It's going to be negative 5 squared. And then we test that out to see if it actually worked, if it's true. So really that's 6x minus 5 times 6x minus 5. And my first is going to be 6x times 6x, which is 36x squared. My outside, I'm foiling, is 6x times negative 5, which is going to be negative 30x. My inside is negative 5 times 6x, which is also negative 30x. And my last is negative 5 times negative 5, which is plus 25. And that negative 30x plus negative 30x simplifies to be negative 60x. And we have a match. 36x squared minus 60x plus 25 is the same as 6x minus 5 and the square of that. So it's the square of the difference of 6x and 5. 6x minus 5 in parentheses squared equals this, and we have solved it. All right, I think I have time to do, I'm going to go ahead and do this one. And so this one has 4 terms, and they're all different degrees. And the method that you might want to look for first with this sort of thing is to see if you can see what happens if you factor out the greatest common factor here. This is a factoring by grouping situation. So what's the largest common factor here? 12x cubed plus 28x. Okay, the largest common factor there is going to be, so if you look at the number part, the largest common factor of 12 and 28 is 4. And then you looked at the variables, the largest common factor of those is x squared. And then we see what we have left. So if I factored a 4x squared out of 12x cubed, I'm left with 3x. If I factored a 4x squared out of 28x squared, I'm left with 7. Now, I'm going to look and see what I've got over here. Well, this other part here, negative 3x minus 7, looks an awful lot like 3x plus 7. If I factored a negative 1 out of both of those, I end up with this. So I'm going to factor a negative 1. I'm going to be left with positive 3x plus 7. So now I have the same factor here and the same factor here. And I can use the distributive property to say, okay, this is times this, and it's also times this. So overall, this is going to equal 3x plus 7 times the difference of these two terms, because they're both times 3x plus 7. So 4x squared minus 1. At that point, you might think, well, I'm done. But you're not necessarily. You could actually go one more step. So if you got this far and you stopped, I'd give you partial credit. But really, you want to look at this and notice it's a difference of squares. 4x squared is a square, and 1 is a perfect square. So we can take it one more step, and it's going to be 3x plus 7 times, well, we're going to have a difference of squares. We're going to have 2 binomials. First one is going to start with a square root of 4x squared, which is 2x. And I'll have a 2x plus something and a 2x minus something. And the plus or minus something is going to be the square root of 1. So plus 1 and minus 1. And we're done. We have factored that. We used a factoring by grouping approach. And then we're able to take these same factors, 3x plus 7 and 3x plus 7, and take advantage of the distributive property to put that together. 3x plus 7 times 4x squared minus 1. And then, since this is a difference of squares, we can take that part and turn it into 2x plus 1 times 2x minus 1. And that is fully factored. I hope these videos have been helpful to you. And let me know if you need some practice problems of any of these sorts. I have plenty of them so that you can prepare for any do-overs.